Okay, in this video I'm going to solve a couple of problems with derivatives. So, y is equal 3 times 1 minus sine x over twice cosine x. Okay, we need to take derivative since we have here division, right? So we are going to apply quotient rule, and the quotient rule says u divided by v prime is equal u prime v minus v prime u divided by v squared. Okay? All right. So, before I start taking derivative, I want to take out 3 over 2 coefficient, right? And it's going to be 3 over 2, 1 minus sine x over 2 over cosine x prime, right? So let's see. This is going to be my u, the 1 minus sine x. This is going to be my v. Cosine x is my v. So, y prime is equal 3 over 2. And we have, so u prime, which means derivative of 1 minus sine x, is going to be negative cosine x, right? Derivative of sine is cosine x. Since we have here negative sign, so negative sign move in front of cosine. Because derivative of 1 is 0, and we have left negative cosine. And this is multiplied by v, which is cosine x. Next, minus v prime, which is derivative of cosine x. Derivative of cosine x is negative sine x. All right? So this is going to be negative sine x times 1 minus sine x. Okay? Divided by v squared, which is going to be cosine square x. All right. Now all we have to do is simplify. Y prime is equal 3 over 2 negative cosine square x plus sine x times, well, let's multiply, might as well, okay, plus sine x and minus sine square x, right? Divided by cosine square x. And result, it's going to be here 3 over 2. I'm going to excuse me, use formula 1 plus, this is not a derivative, it's just a formula, tangent square x is equal secant square. So I'm going to apply it. So before I apply, I need to divide every single term by cosine square x, and it's going to be negative 1 plus tangent. Okay, let me go step by step so there won't be any wandering around. Negative cosine square x over cosine square x plus sine x over cosine square x minus sine square x over cosine square x. So therefore, we are going to have 3 over 2, and that's equal negative 1 plus tangent x secant x, because what I'm doing here, let me break down cosine x. I can write down cosine x, right? So this is gonna be my tangent, right? And then what I have, 1 over cosine x, right? This is going to be my secant, all right? And minus tangent square x. Okay. So y prime is equal 3 over 2 tangent x secant x minus secant square x. Where from? Let me write down here, do drafting. I have -1 negative tangent square x, right? So I'm going to rewrite -1 plus tangent square x, which is equal, right here, secant square x. Yes? So, but since I have negative, in front of parentheses I will put negative secant square x. And here it is. All right? So from here, I'll write down y prime is equal 3 over 2. Take out secant, and in parentheses I have tangent x minus secant x. All right? Now, I would solve, and usually I do solve different way, different meaning via multiplication, because I don't like to deal with quotient, but it's a matter of taste. Somebody like it, I don't, because to me quotient is kind of too long. Instead, I would turn this into derivatives of multiplication. Let me show you how I would do it. So I would solve using multiplication. So to write down formula, u v prime, right here, is equal u prime v plus v prime u. Okay, so y is equal 3 times 1 minus sine x over twice cosine x. So y prime is equal 3, okay, no. Let me, okay. This is equal, this is how I'm going to represent 3 over 2, right? I'm going to do, let me see which way I will do. All right, I will represent 1 over cosine x and minus sine x over cosine x. Yes? All right. So, and then y is equal 3 over 2. 1 over cosine x is secant x. And sine over cosine x is a tangent x. Correct? Okay. So from here, I need to find derivative. Y prime is going to be 3 over 2 stays outside. Coefficient has nothing to do. Derivative of secant x is secant x times tangent x. Okay? So which is going to be secant x tangent x. And derivative of tangent x is equal secant square x. Why this one formula I put it so small? Let me clean this and make it a little bit bigger, otherwise it seems to me it's not even seen. There we go, much better. So secant tangent and then minus secant square x. We good? All right, so that's it. So from here, y prime is equal 3 over 2. I'm taking out secant, and I'm getting tangent x minus secant x. And that's all. Now you tell me. I was going to do a multiplication, but I saw and I figured out that I can't go even without multiplication. Just break down these terms and just take derivatives. It's subtraction. Even easier than I was thinking. Okay. So let's do another one. Number 2. Y is equal cosine 2x to power 4 minus 6. Obviously, we are going to use rule of chain, right? So rule of chain says, first we need to take derivative of entire cosine, right? And because instead of just x, we have 2x to 4 minus 6, right? Instead of standard form cosine x, we have cosine 2x to power 4 minus 6, which means we have the phase shifting, we have shrinking, and so on. So we need to get inside and then take derivative of this inside also. So let's do it. Y prime is equal. Derivative of cosine, we have it here, is negative sine, right? Right here. Which is going to be negative sine 2x to 4 minus 6 times 2x to 4 minus 6 prime, which is derivative. Next, y prime is equal negative sine 2x to 4 minus 6. Well, 2x to 4, how we take derivative? Let me rewrite again n at x to power n. Derivative is equal n times x to power n minus 1. So it's going to be, we have 2, right? 4 comes in front, 4, and x and 4 minus 1 is 3. And derivative of 6 is 0. So we have negative 8x cubed and sine 2x to 4 minus 6. Okay? And we are done. Next one. We have y is equal 5x squared plus 2x minus 1. All right. To take derivative, first of all, I am going to rewrite it in the format of rational fractions. 5x squared plus 2x minus 1. You always want to do that. So before you take derivative. So from here, y prime is equal. So we are using the formula x to power n prime. It's going to be 1/2 comes in front. And we have 5x squared plus 2x minus 1. And we need to do 1/2 minus 1, right? Because of this formula, n minus 1. And it's going to be negative 1/2, right? And then we need to get inside, right? we took derivative for this entire the entire expression, 5x squared plus 2x minus 1 to power 1/2. So practically we took derivative of 1/2. And now I have to take derivative of inside, get inside and take derivative of 5x squared plus 2x minus 1. And it is gonna be, so, okay, let me go slow. I always trying to jump, it seems to me. I'll go step by step. Plus 2x minus 1 prime. So I'm getting inside and taking derivative of the argument. All right, so from here, y prime is equal. Since we have negative 1/2, it's going to bring down, right, to denominator, 5x squared plus 2x minus 1 to power 1/2. And what is going to be left, the derivative of 5x squared? It's going to be 10x, right? Because this 2 is going to come in front. 5 times 2 is 10. And 2 minus 1 is 1. So I practically used, again, x to power n prime is equal n times x n minus 1. Next. Derivative of 2x is going to be just 2. Why? Because derivative, let me do on the side, drafting, 2x prime, it's equal, by the same rule, 2 times, so since x to power 1, this 1 comes here, right? And I will have 1 minus 1, which will be 2 times x to power 0, which will be 2. This is why when you have 5x, 6x, 10x, whatever x is gone, you have only coefficient left. We clear? Okay. So 10x plus 2, all right, put in parentheses. And we have y prime is equal, finally, 10x plus 2 comes to numerator. In denominator I have 2. And 1/2 I convert again back in square root, 5x squared plus 2x minus 1. Okay, and we are done. Let me solve one more, number 4, and I will be done. So y is equal e to power 3x plus 2. So we know that derivative e to power x prime is equal e to power x. From here, y prime is equal e to power, instead of x, we have 3x plus 2, right? So which means we have to treat 3x plus 2 as a x, e to power x, and then get inside and take derivative of 3x to power 2 plus 2, because it's not in the standard format e to power x. Whatever is not in the standard format, we have to get in and take derivative. E to power, derivative of e to power 3x plus 2, it's going to be e to power 3x plus 2. And then times derivative of 3x plus 2 prime. This is going to be, so e to power 3x plus 2 times derivative of 3x is 3 and derivative of 2 is gone. So from here, we get the result 3e to power 3x plus 2. Okie dokie, I am done. And I believe I will continue some more derivatives. We will solve quite a few derivatives and trig functions and problems with limits before I finally move to integrals. We are going to do integrals, which is calculus 2, and at the end we will move to calculus 3, which is my favorite subject. It's going to be derivatives and the integral in 3D dimension. That's a high math. All right. Thank you very much for watching, and I see you again in next video.